Hello students and welcome to section 1 of geometry. In this section we are going to do chapter number 1, similarity. So before we start we need to first clear out what is the difference between congruency and similarity. As you all have learned in your previous classes that whenever two triangles are drawn and there is some kind of symbol like this, that means these two sides are congruent. So what is the difference between congruent sides and similar sides? So before we start on with our topics in similarity, we'll first clear out the difference between the two. So let's say I have a triangle ABC here, ABC, and another triangle PQR. So if AB is equals to PQ, AC is equals to PR, and BC is equals to QR, that means triangle ABC is congruent to triangle PQR. Now in this test, each side is equal to the other side of the triangle. That means AB is equals to PQ, AC is equals to PR, and BC is equals to QR. Now all of this comes under congruency. Now what are similar triangles? So let's say I have triangle ABC here, and now I have a triangle PQR which is much larger in size. Now clearly, let's assume AB is not equal to PQ, because in this particular diagram I'm defining that PQ is much larger than AB. But in similarity, what we are concerned with is the ratio of AB upon PQ or the ratio of PQ upon AB. We are not concerned whether the sides are equal or not. All we are concerned about is whether AB upon PQ, the ratio, is equal to all the ratios of the all the ratio of sides of the triangle. So what I mean by this is that AB by PQ is equal to AC by PR is equals to BC divided by QR. This means that all the sides are in equal proportion, and when this occurs, that is when both triangles ABC and triangle PQR are similar to each other. So the difference between similarity, this here is our similarity. The difference between similarity and congruency is that congruency is related to equal sides and similarity is related to proportions. So we need equal proportions for triangles to be similar. Now once we have cleared this, we have to move to our first topic from the chapter number 1, which is ratio of areas of two triangles. Now before we start, first we need to define what is area of a triangle. So area of a triangle is defined by 1 by 2 into its base into its height. Height can also be called altitude. The terminology does not matter. All that matters is that the formula is correct. So area of triangle is equals to half into its base into height. Now base can be any side, but height is always the length of the length from the base to the opposite vertex. So I'll draw a diagram and explain what and how to choose base and height. So let's take a triangle here. This is triangle ABC. Now initially I'll start with base is equals to BC. So now if my base is BC, that means my height has to be from the opposite vertex to BC. So the opposite vertex to BC is the vertex A. So my height becomes, in this case, I'm naming it D, the altitude which intersects the side BC, in point D, this altitude is called as AD. So in this case, my height becomes AD. Now, in the second case, I'll be choosing my base as AB. So in this case, my base is AB. So when my base is AB, the opposite vertex becomes the vertex C. That means now AD cannot be used as the height because I chose my base as AB. So in this case, I have to again make sure that there is a line intersecting from the vertex C to the side AB in point, let's say this point is E. So for when I choose base AB, my height becomes CE. And similarly, when I choose base AC, I have to choose the side opposite to the vertex. I have to choose the vertex opposite to the side AC. So in this case, that opposite vertex is B. So all I have to do is draw this altitude. So my height here becomes, this is the line from B to AC will intersect side AC in point F. So this point can be called as BF. Now, one very important definition that you all need to remember, that height or altitude is always perpendicular, to the base, which means that this is 90 degrees and this is also 90 degrees. We'll be learning later on why this is very important. Now, once we have cleared what is base and height, we have to move to the conditions which are necessary. So this is condition number 1, when we have two different, or rather not two different, two triangles. We have two triangles with different sides. So let's choose two triangles. I have here triangle X, Y, Z, and here I have triangle P, Q, R. Now in this diagram, some of you might wonder that both these triangles look the same, but as long as the question or the examiner or the teacher does not define a value to the side, do not assume any kind of value, or do not assume that the triangles are same. Because if I say that this value is 3 and this value is 7, then clearly XZ is smaller than PR. So do not get confused by the diagrams. Make sure your facts are correct and the information that you pick from the question is precise. Now, back to our concept here. Now, for triangle XYZ, area is equals to half into base into height. So my base here, I'm going to take my base as YZ, and to YZ, I'll have to build an altitude, which is, I'll name it A. I'll name it XA. So my altitude becomes AX. And similarly for triangle PQR, my area becomes half into QR. Again, I have to draw an altitude from vertex P to the side QR, and this I'm going to name as B. So this becomes QR into PB. So the ratio of these two triangles can be simply written as area of triangle XYZ. This is equation 1. This is equation 2, divided by area of triangle PQR is equals to 1 by 2 into YZ into AX divided by 1 by 2 into QR into PB. Now As we can see, this 1 by 2 and this 1 by 2 is common. So all we have to do is cancel these values. So I'll be left with yz into ax divided by qr into pr. So whenever I have two triangles with different sides, the ratio of the area is equals to the base into height of triangle 1 divided by base into height of triangle 2. So what I'm going to do is I'm going to name this triangle as triangle 1 and this triangle as triangle 2. I'm going to say that yz is equals to base 1 and ax is equals to height 1. And in second case, I'm going to say qr is equals to base 2 and pb is equals to height 2. So all I have to do is now replace yz with the values that I have given to yz. So area of triangle xyz divided by area of triangle pqr is equals to, from our previous we can write yz as b1, so this becomes b1. We can write ax as h1 into h1 divided by qr as b2 and pr as h2. Now my first triangle is triangle xyz, so I can simply write triangle xyz as area of triangle 1 divided by my triangle PQR is my second triangle, so I'm going to write it as area of triangle 2 is equals to B1 into H1 divided by B2 into H2. So this is the formula that we have for our ratio of areas of two triangles. Area of triangle 1 divided by area of triangle 2 is equals to base of triangle 1 into height of triangle 1 divided by base of triangle 2 into height of triangle 2. Now, once we are cleared with this, we'll move on to a specific case. Let's assume that the base of triangle 1 and triangle 2 are equal. Now, what happens if the bases are equal? So, let's say I have triangle again x, y, z and triangle p, q, r, and in this case yz is equals to qr. Now we know from the previous slide that area of triangle 1 divided by area of triangle 2 is equals to b1 into h1 divided by b2 into h2. Now this particular condition says that yz is equals to qr, but yz, as we learned, yz is equals to b1, so I'm going to write b1 here and qr is equals to b2. So from this condition I can simply say that when b1 and b2 are equal, I can cancel these two values out. So if b1 and b2 are equal, so I have simply can cancel them out. So what I am left with is area of triangle 1 divided by area of triangle 2, which is equals to height of triangle 1 divided by height of triangle 2. Now, as base of two triangles can be equal, in similar case, height of the two triangles can also be equal. So let's say height of triangle 1 and triangle 2 are equal. Again, we use the formula that we obtained from our third slide. We have area of triangle 1 divided by area of triangle 2. This is equals to b1 into h1 divided by b2 into h2. And as the condition states that heights are equal, so I can simply say that h1 is equals to h2. So all I have to do is, again, these two values are equal. All I have to do is cancel them out. So I'll be left with b1 divided by b2. So whenever height of two triangles are similar, then the ratio of their areas becomes equal to the ratio of their bases. So area of triangle 1 divided by area of triangle 2 is equals to base of triangle 1 divided by base of triangle 2. Now, once we are done with this, let's assume our last condition. So in our last condition, if both base and height are equal, so if both base and height for both triangles are equal, that means B1 is equals to B2 and H1 is equals to H2. So this implies that area of triangle 1 divided by area of triangle 2, as we know the formula is B1 into B2, sorry, B1 into H1 divided by B2 into H2. Now all I have to do is cancel out the values. B1 and B2 are same, so I'll just cancel them out, and H1 and H2 are same, so again I'll just cancel them out. So what I'm left with is equals to value 1. So if both base and height of the triangles are equal, that implies that the ratio of the triangles are is 1, or you can say that the area of the triangles is same. So this is equals to 1. This can also be said as area of triangle 1 is equals to area of triangle 2. Now these are the three, or rather four conditions that are very important in the ratio of areas of two triangles. We'll finish off this particular section with one example from page number 1, or rather page number 3, and this section will end then. In the next section, we'll move on to solved examples and we'll choose some questions from our practice set. So this is a question from page number 3, example number 1. Now we have a diagram here. I'll just take some time to draw the diagram. So this is 90 degrees, this value is F, this value is D, this is C, this value is E, this vertex is A, this is B. Now the question says that in the adjoining figure, AE is perpendicular to segment BC and DF is perpendicular to line BC. If AE is equals to 4, that means this value here is written as 4. Make sure you write the values given in the question in your diagram so that you do not face problems while solving the questions. And the value DF is equals to 6. And so here we have given AE perpendicular to BC and DF perpendicular to again BC, or rather line BC. AE is equals to 4 and DF is equals to 6, and we have to find area of triangle ABC divided by area of triangle DBC. Now what I'm going to do is I'm going to pick this ABC triangle out separately and this DBC triangle out separately, and we are going to see what happens. So on to our next slide. I have a triangle ABC here. This is A, this is B, this is C. From the diagram we can see that AE is perpendicular to BC. So all I have to do is draw the diagram as it is. So this is perpendicular. The value of AE is equals to 4. Now this is my triangle number 1. So now as I can see that from triangle 1, my area for triangle 1 becomes base into height. Base for triangle 1 into height for triangle 1. Now in this case, AE is an altitude to the side BC. So I have to assume that AE is the height. So therefore, in H1 I can write AE, and as AE is perpendicular to BC, I have to assume that the base is BC. Now I do not know the value of BC, so let BC be as it is, and the value of AE is 4. So area of triangle 1 becomes BC into 4. Now to our triangle 2. We have DBC. So this is my point. This is D, this is B, this is D, B, C. And now remember, line BC is extended. So I need to make sure that this line is extended this way, and I have a perpendicular here. And this point is F. So area of triangle 2 is equals to, again, base 2 into height 2. Now here, as DF is perpendicular to the line BC, we have to assume that DF is the height or altitude from base BC. So this becomes DF, and as in triangle DBC, CF is not a part of triangle DBC. So what I have to do is I have to assume that the base here is BC again. So this value is BC. So area of triangle 2 becomes BC into 6. Now all that is left is to divide these two values. So I have area of triangle 1 divided by area of triangle 2, which is equals to BC into 4 divided by BC into 6. Now as you can see, BC and BC is common, so all I have to do is cancel these values out. So I am left with area of triangle 1 divided by area of triangle 2 is equals to 4 divided by 6. 4 and 6 have 2 in common, so I can simplify them. And write them down as 2 divided by 3. So area of triangle 1 divided by area of triangle 2 is equals to 2 divided by 3. Now this is the only question that we're going to see at in this particular section. Now before we end this section, we're going to once again revise the definition of height to the base. So in any triangle, here the definition of height is the perpendicular distance from the side from the side to the opposite vertex. So height is defined as the perpendicular distance from the side to the opposite vertex. So as we can see in this case, this is the perpendicular line for this is ABC. For base AC, this is the perpendicular distance, and for base AB, this is the perpendicular distance. Now some examples, as we saw in our previous solved examples, might have a different triangle. So let's say I have a triangle like this. So as you can see, there is no perpendicular value here, but if I choose ABC and BC is my base, the height from opposite vertex, as BC is my base, so my opposite vertex becomes A. Now the moment my opposite vertex becomes A, I need to draw a perpendicular line from BC to A. So the only perpendicular line is this particular line. And therefore, sometimes the height, even though not being inside the triangle, can be measured. So this is how height is defined the perpendicular distance from the side to the opposite vertex. Now in the next section we'll be doing some questions in order to make sure that you understand the concept of height correctly, and then we'll move on to our solved examples. Thank you, and this section will end now.